Right, so in this video, I'm going to talk about metal reactivity, right? So first, right, metals will like to lose electron to form cations because metals are usually on the left-hand side, so their group number will be small. They will have also small valence electron, so they would like to lose the electron. So once they lose the electron, proton will be more, so proton will be the winner. So they will form positive charge, so they will form cation. Okay. Now in this worksheet, we're going to have down the group and across the period. So first of all, before we start, I ask everybody to write down the key thing is less easier will be less reactive, more easier will be more reactive. We don't use the word difficult because I want to make the collection less easier, less reactive, more easier, more reactive. Okay. So if you look at the periodic table, right, this is like the front page, and nucleus is always on the top. Nucleus is the positive charge. And we compare Na and K. Now they are on the same group, so we're talking about down the group. So we write down their period, group number, valence electron, and based on the valence electron, they're going to lose how many? So sodium will be 3 period, 1 group, group 1, 1 valence electron, and lose 1 electron. And potassium will be in period 4, group 1, 1 valence electron, so they want to lose 1 electron too. Now they both of them want to lose 1 electron, but Na is going to be less easier to lose the electron because Na is going to be very close, right? The valence electron is very close to the nucleus, right? It's only 3 shells, so the Na is closer to the nucleus, so it's not easy to lose the electron because the nucleus is going to attract the electron. So less easier to lose the electron, we can say less reactive, so Na will have smaller reactivity. Now if you compare to K, K is more easier to lose electron because the K is further away. The valence electron is furthest away from the nucleus because of 4 shell, period 4. So you have more shell, it's more easier to lose the K because K is further away from the nucleus, right? So it's a more reactive, it's a bigger reactivity. So based on this, the metal reactivity should be increasing down the group from smaller to bigger. And the one on the bottom, which is K, should be more reactive than the one on the top. Okay? Now, when we go to the across the period, we got to do the same thing. We compare the Na and Mg. So Na has 3 period, 1 group, group 1, 1 valence electron, and you want to lose 1 electron. And Mg is going to have period 3, group 2, 2 valence electron, and to lose 2 electron. So they both on the same period, but Na want to lose 1 and Mg wants to lose 2. So both Na and K have 3 shells because they both have period 3. But Na is more easier to lose electron because it only needs to lose 1 electron, so it would be less energy need. But Mg, on the other hand, would be less easier to lose electron because it needs to lose 2, will be more energy. So Na, if you have fewer electron, right, you have only 1, so I would only need to lose less electrons, so I'll need less energy, so it would be more easier for me to do the job. So more easier to lose electron, more reactive will be bigger reactivity. And the Mg, on the other hand, because I have more valence electron, I need to lose more electrons, so it will be more energy needed, and then will be less easier for me to finish the job, will be less reactive and smaller reactivity. So when you're reading across the period from left to right, the metal reactivity should be decreasing across the period because from big to small. And then the metal on the right-hand side, which is the Mg, should have smaller reactivity or less reactive than the one on the left-hand side. So now we can combine the two. We say down the group is increasing, across the period will be decreasing, so we write down the notes here. And then if you just look up the red thing, okay, so from the top to the bottom is increasing. So from the top to bottom will be small to big. And then if you look at across the period is decreasing. So from the left to the right will be from big to small. Okay. Now if you combine the 2 trends together, you will see that small, big, right? Look like this way. So when you combine the 2 trends into one, we're going to draw like this. Okay, so the smaller one is always the one without the head, without the arrowhead, and the big one with the arrowhead. We always want to circle small and big because people will think this is boron, this is sulfur. So we only use one arrowhead, which is the bigger one. right? The bigger one with arrowhead, the smaller one with double arrowhead. We're going to use this trend, okay, this one, to describe the metal reactivity, okay? So the left-hand side question is which one is more reactive, Mg or Ca? So we first draw the trend, right? Same trend all the time, right? We draw the trend with the arrowhead on the big and smaller with the small one. And we can find the position of the Mg and the Ca on the periodic table. We copy the position and we turns out find out that Mg is on top of the Ca. We copy. So which one is more reactive is which element is going to be closer to the bigger one, which is Ca. So Ca will be the answer. Ca is more reactive than Mg. Right? Now let's look at this side is which one is less reactive. So we draw the trend, right? We draw the same trend, small and big. And we copy the position Ca and K. We find out the K is on the left, C on the right hand side. Now, which one's less reactive? That means which one's going to be closer to the smaller side, which is Ca. So Ca will be the answer. Ca is less reactive than K. Okay. Now, on the bottom here, okay, so we can actually do like one question here. So if it's increasing, will be from small to big, right? And the arrow, we're going to use this arrow because this arrow is the big mouth always facing to the big. Okay, so small to big. So we draw the trend, we copy the position of the 3, which is here, and we're going to draw the write down the rank. Okay, so since we're going from small to big because of increasing, so we're going to start with AL because A is near the S. So AL, and then this symbol, we follow the symbol, right? AL smaller than Mg, smaller than Na. So that's the answer. Right, so the same thing for this one, right? So the increasing will be small to big. Now if it's decreasing, we all the other way around will be big to small. And we always draw the big mouth facing to the big side, big mouth. So it will be this symbol. We draw the trend. Now we have 5 elements here. So I would suggest you to write down one and then cross it out. Write down one and you cross it out. So you will not leave any left over. So we copy the element's position right here. We draw the trend. And then we say, okay, decreasing is from big to small. So where we start from? We should start from Fr, Cs, Na, Mg, and Al. And we're going to use this symbol for all the time. So this is the answer.